Good morning, good afternoon, good evening, wherever you are. I am Nick Chase from Mirantis, and welcome to today's webinar, Why the Edge Isn't Hype and What You Can Do About It. Our guest speakers today are Yves Boudreau from Ericsson and Satish Salagame from Mirantis. Let's go ahead and do some introductions. First, we have with us Yves. Yves has been around for about 20 years in this space, and he is currently the VP of Partnerships and Ecosystem Strategy for Edge Gravity by Ericsson. He's going to tell us a little bit about that. Good morning, Yves.
Good morning.
Okay, and Satish is Director of Engineering for Networking here at Mirantis. Also been around for quite a while. Man, I feel old saying that about all of us, but we've been doing this for a long time. All right, so let us take care of a little bit of housekeeping before we get started. If you notice on the right-hand side, usually you will see the GoToWebinar pane. There are some questions. There is a place there for you to put your questions, and we're going to hold all those till the end, but please feel free to put them in throughout so that we can gather them together and get them organized for the end. So if you are wondering whether you will be able to get the slides at the end and the recording at the end, the answer is yes, so you don't have to ask, but I am taking a poll on how many people will ask that anyway. So, you know, if you want to submit that as your guess, you can go ahead and do that as well. All right, so moving on, let's take care of the agenda. Let's take a quick look at what we're going to talk about here. We are going to talk about edge computing and what makes it different from cloud computing. Satish is going to kind of give us a technical overview of the vagaries, if you will, of edge computing, what it's used for, why it's important. He's going to talk a little bit about MCP Edge and how that fits in, but really this is really more of a technical presentation. And then we'll also talk about Virtlet and what happens when you've got VMs that you need to run at the edge. And then finally, after kind of talking about the concepts of what goes on, Yves is going to give us a look at what that actually looks like in the real world by looking at a real, actual, honest-to-God project, that product even that is out there in the world. So let's move on and get started. So Satish, tell us now where we stand. What is so important here about edge computing, and how is it different from cloud computing?
Thanks, Nick. Thanks for the introduction. Hello, everyone, and thank you very much for joining this webinar today. So there are multiple ways we can look at edge computing. From an infrastructure-centric point of view, edge computing is essentially applying cloud principles at the edge of the network, close to the user. So when I say that, what do I mean by that? So what I mean is compute, storage, and network virtualization that we are all familiar with in the cloud computing world. Resources on demand, API-driven approach, automated lifecycle management, and use of commodity hardware. So these powerful cloud principles really make the network edge highly flexible and programmable. So if we look at the edge computing from a network operator point of view, it's really the convergence of IT and telecom networking. So as we show in this picture here, we can have a variety of devices like mobile phones, IoT sensors, connected cars, all of them connecting to access networks using different access methods. It could be radio access, Wi-Fi, cable, or fiber. So then we have the aggregation network, the regional POP, and the core cloud. So depending on the use case that we are dealing with, the edge cloud could reside in several of these network layers. So this basically allows network operators to really open up their networks to new business opportunities and new value chains that just did not exist before. So finally, if we take a look at edge computing from an application-centric point of view, it's really all about new, innovative, and immersive edge applications. This, I believe, is a great opportunity for app developers to create applications that are number one, tailored to local conditions, that provide highly contextualized services, and moreover, these applications can have low latency and high bandwidth guarantees on the edge because of the proximity of the edge cloud to the user, and also the way the edge is designed to guarantee some of these characteristics. So eventually, these innovative applications, edge applications, are the ones that are going to have a significant impact on the overall success of the edge computing.
Excellent. Um, so give us an idea of specific use cases where these things are going to be important.
Yeah. So let's look at edge use cases. At a high level, when we look at edge use cases, they fall into two buckets. The first one is the third-party edge applications. These are the more interesting ones. So there are multiple categories you can see here. Real-time category. These are applications requiring extremely low latency, low jitter, and some of them even high throughput. Think about AR, VR type of applications, connected cars, tactile internet, Industry 4.0, smart cities. They all fall into this category. So if we look at the immersive type, these are applications requiring extremely high throughput. 4K video streaming, 360 video, those fall into this category. Cost reduction is basically saving upstream bandwidth and also saving upstream processing in the central cloud. Uh, so typical applications here are video surveillance, IoT gateway, big data analytics. They all fall into this category. Now, if we look at self-contained, these are really interesting use cases here. This includes stadium events, concerts, and airports. And this is where network slicing plays an important role. Finally, looking at the private slash enterprise category of applications. So here you have applications like RAN to enterprise breakout, universal CPE or virtual CPE, those kind of applications fall into this category. Now, if we look at the other big bucket that I talked about, and that's the operator applications. So here we have analytics. This is basically collecting large amounts of data and even running analytics on the edge itself, and then sending small amounts of that, probably summary information to the core. So this is a typical data reduction type of application. Then compliance is interesting. Compliance includes copyright information, geographical data placement, and those type of applications. So copyright enforcement during sports events or concerts, they can be implemented in an interesting way. For example, you can have an edge application that either disables upstream transmission or even reduces resolution in a concert or a sports event. And edge application can also be deployed to enforce data to reside in a specific geography. Now, if we look at security, so this is basically moving the security perimeter close to the source. So by this, we can block security threats at the edge of the network and protect the core network. NFV is a very important category here because Edge is ideal for running different types of VNFs, access VNFs, like, for example, VRAN or CRAN or VCMTS for the cable. security VNFs, we can have virtual firewall, virtual IDS, IPS, that's intrusion detection, intrusion prevention, unified trust management, virtual UTM, several content filtering type of VNFs. We can have service enhancement VNFs, like for example, virtual DPI, WAN optimization, policy type of VNF. So VNF is a very important category, and that's why you typically see the edge infrastructure very similar to the NFVI or the NFV infrastructure.
Excellent. So what are the requirements as far as infrastructure is concerned?
All right, so we just looked at what is edge computing at a high level, and we looked at some of the key use cases. So basically, those drive a lot of requirements for the infrastructure. So let's look at those requirements. Obviously, ultra low latency is extremely critical uh, because edge applications are going to demand less than 10 millisecond type of latency from the infrastructure. High network bandwidth, especially when we are talking about immersive edge applications that I described in the previous slide. So high network throughput becomes extremely critical. When we are talking about edge clouds, there are a lot of cases where we have to deal with constrained resources, space, power, and cooling constraints, because we are not going to have the same kind of environment that we have in a large data center. So there is need for ruggedized racks in some use cases, and in a lot of use cases, security concerns exist, including physical security of the edge cloud itself. And it's very important for the edge cloud to have flexible infrastructure. So this is where you have to iterate and evolve to new requirements based on the type of use cases that need to be deployed in an edge. The edge architecture needs to be different. This is where use of SDN, NFV, network slicing, ability to configure a network slice appropriately for a given use case. All these requirements become extremely important for the edge. And obviously high performance, because we are going to be dealing with small footprints in an edge deployment. So we need to squeeze the best performance out of limited resources. So this is where things like CPU, properly managing CPU, memory, storage, enhanced platform awareness, data plane acceleration, all these known techniques that we popularly use in the NFV world become important here. So now, if we look at the management type of requirements, because it's going to be a highly distributed architecture here. We are going to have thousands of large geographically distributed edge clouds. Therefore, common management plane becomes an extremely important requirement. It's almost impossible to manage these thousands of distributed edge clouds using any manual approach. So automation is the key here. Zero touch provisioning, zero touch LCM, zero touch operations, LMA type of capabilities are not just necessary. These are mandatory requirements here. And then compatibility is another key requirement, because edge infrastructure needs to be compatible with Mano. Edge clouds are not going to run in isolation. It's very important to have both a central management capability and also ability to work with industry standard management and orchestration components, like ONAP, Cloudify. So those compatibility with those are also important. And then workload diversity is an interesting requirement, because ability to support VMs, containers, and bare metal workloads, depending on the type of edge applications that we are running, depending on the VNFs that we need to run on the edge cloud, it's important for the edge to support all kinds of workloads. So that's going to be critical, and it also becomes important because at some point we are going to have orchestrators making the decision of which edge application needs to run on which edge cloud, with those kind of automation, flexibility, workload diversity becomes important. And we already talked about small footprints. In some cases, there will be requirement to support just one node edge cloud, or 3 to 6 node edge cloud, half rack, full rack. So ability to have small footprint is also a critical requirement.
All right. So now that we know what we need, how does that relate to, say, MCP Edge?
Right. So now let's jump into the Mirantis Cloud Platform Edge stack, and we can see how we try to support some of the requirements that we talked about. So here is a high-level picture showing the components of the MCP Edge Cloud stack. So we have the management plane that I briefly talked about. So this includes the Mirantis Cloud Platform for infrastructure management and monitoring. As I said earlier, the key strength of Mirantis Cloud Platform is really in flexible management and monitoring of infrastructure using infrastructure as code approach. So that's the key strength of MCP. Then we have Cloudify for VNF and application orchestration. So I say Cloudify here, but it could be any orchestrator, ONAP in the near future will be integrated with Stack, and we will have support for that as well. So when we look at the individual edge cloud here, we are showing two small footprints of Kubernetes Edge Cloud in this picture, but it doesn't have to be all Kubernetes. We can have small footprint OpenStack Edge as well. Within each edge, we can see the drivetrain agent here, and we also see the orchestrator agent, the Cloudify agent in this example. So these agents provide basic local management of the edge cloud and basic local orchestration functions. And they also communicate with the orchestration component on the management plane. We see that, we are going to see that a little bit later. One more interesting component that you see in this architecture is the Virtlet component, which is basically for running VMs as VMs within Kubernetes pods. And these are very helpful in running VNFs in a pure Kubernetes cluster. And once again, we are going to talk a little more about this soon. In addition to, apart from this, within the edge architecture, we have support for data plane acceleration using SR-IOV and DPDK, and these are extremely critical for achieving high network throughput and low latency, as we discussed a couple of slides ago. Then the last comment here is that there are multiple options for L3 connectivity to the edge cloud. So the management plane communicates with the distributed edge clouds over an L3 network.
All right. So that's a general idea of all this. Can you give us a little bit more of a deep dive into what an edge cloud actually looks like and how it gets implemented?
Right. So we looked more at the individual cloud. Now let's take a step back and look at it from a higher level. So when we are trying to deploy and operate a large number of edge clouds, remember we said it could be hundreds or thousands in some case. So when we do this, it's extremely important to have highly automated central management plane. So I already talked about zero-touch provisioning, zero-touch operations, and zero-touch LCM. These are all mandatory requirements here. So compatibility with Mono and application orchestration is also obviously critical. So in MCP, we have a master of masters that basically manages the distributed set of edge clouds. So in this picture, you can see one OpenStack edge cloud and two Kubernetes edge clouds that are being managed by this master of masters. The Salt Syndic component that you see here, uh, these are local management agents that I talked about in the previous slide, and these are responsible for local management of the cloud and also for communicating with the central master. Again, the key goal here is to achieve full automation and at the same time be compatible with standards-based orchestrators like ONAP or Cloudify. So that's the big picture here.
Okay, so what about, let's dig a little deeper into a single cloud. What does it look like and what's so special about it?
All right. So let's dig deeper now and look at MCP Kubernetes Edge Cloud. And in particular, the focus on this slide is how can we run VNFs in this kind of an environment. If you think about it, Kubernetes is very well suited for a small footprint edge cloud. This is because Kubernetes is easier to manage and containers have much lower overhead compared to VMs, which means we are left with more resources for running edge applications or running VNFs, even in a small edge cloud. So, but one of the challenges when you have a pure Kubernetes cluster is running VNFs in Kubernetes containers, because if you look at it, a large portion of VNFs in the market today still run as VMs. They are not designed to run in containers yet. There is quite a bit of effort in that direction, but still a large portion of VNFs still run in VMs. So the question is, how do we run these VNFs, which are VMs, in a Kubernetes Edge cloud? So at a high level, if a VNF has to run as a VM, then what we really need is a VM pod, concept of a VM pod in Kubernetes, which can run a virtualized workload. Also, we need Docker pods and these VM pods to kind of coexist and perhaps even be networked together in a seamless way. In Kubernetes, we have the container runtime interface, and we can have a Kubernetes CRI implementation for running these VM workloads. One way to do this is using the open source Virtlet technology. So this is exactly what we currently have in MCP Kubernetes Edge Cloud. And so as we show in this picture, we can have a virtual firewall VNF or a virtual DPI VNF running in Virtlets. And at the same time, we can have containerized edge applications, like, for example, a video surveillance application and media streaming application. The assumption in this picture is that these are containerized and they are running in Docker pods, and these VNFs are still VMs and they are running within the VM pod or the Virtlet pod. So that's basically what we are showing, and so they can kind of coexist, and this makes this architecture very flexible, because now you can run mixed workloads, both VMs and container-based workloads on the same platform here.
Excellent. So tell us some more about Virtlet.
Right. So we have been talking about Virtlet. So let's see what exactly it is. As I said, Virtlet is a Kubernetes CRI implementation for running VM workloads. So it's really targeted at VM workloads that need to behave as containers on the outside, but within the pod, they are VMs. So basically, they can run unmodified OpenStack VM using QCOW2 format. And the other nice thing about Virtlets is, since it's a CRI implementation, it's easy to build higher level Kubernetes objects like services and other higher level Kubernetes constructs using VM pods. And the same kubectl pod commands work with VMs. It's very easy to integrate Virtlet-based VMs within the cluster networking using the same CNI plugins that we use. So those are the benefits of those are the benefits of using the Virtlet. So in terms of other capabilities, VM pods can join Kubernetes cluster like I described. So it's the same pod IP that's used for a VM. So in fact, at a higher level, there is no distinction that the pod is running a Docker container versus a regular VM. And VM pods can be targeted by Kubernetes services, any other higher level Kubernetes construct as I described. And there is support for Cloud Init as well. So we can add SSH keys to VMs running within our Virtlets. It's easy to add extra setup scripts. So and it really makes it easy to run VM-based VNFs in this environment.
Okay, so what does this mean from a networking standpoint? How does that work out?
Right. So that's a good question, Nix, because as you can imagine, networking gets a little bit complicated here, but there are good solutions here. As we show in this picture, we can have Docker pods and Virtlet VM pods network together in the edge cloud. So here we are basically using CNI Genie for multiple CNI support. For the VM pod, let's say you have two interfaces, like we show here, one connecting to a flannel network, and the other could be connecting to an SR-IOV network for data plane acceleration. So this VM pod can be used for running a VNF workload requiring high network throughput going through the SR-IOV network. Now, if you look at the Docker pod also has an interface connecting to the flannel network here, and we can easily configure these networks to achieve control plane and data plane isolation. In fact, that's one of the key requirements when you are running a VNF workload, because a VNF could have multiple VNF components, and some component could be part of a control plane network or a management plane network, and some other VNF component could require a very high network throughput data plane interface like SR-IOV. So this really makes Virtlets very well suited for NFV type of workloads or any networking type workload requiring multiple interfaces and specialized networking, and added to that, they need to run as VMs.
All right. So if I wanted to try this out, what would be a good, easy way for me to do that?
Right. So we have an MCP Edge demo virtual appliance. So Nick, please go ahead and you can talk about this. Yep.
You see what I did there? Yeah. So we have this demo virtual appliance. Basically, if you go to this URL, you can download a set of instructions and a set of virtual machines that have Virtlet pre-installed, so that you can try it out and see how it works and see a VM talking to a container and vice versa, and so on. So go ahead and check that out. So that is a good demo that you can try out for yourself and see how you would use it and so on. But, and here's my second segue, in terms of actual products that are out there, Eve, tell us now about Edge Gravity.
Thanks, Nick. Michelle's just going to make me the presenter. I'll show you guys the
Michelle's
slides here.
going to make you the presenter.
Yep.
There we go.
Well, thanks for joining us today, everybody. Let me know when you guys can see the slides. I'm going to change this up here a little bit. There we go.
We are good to go.
All right. So thanks for joining us today, everybody. Last week, we actually went through a slight rebrand to try and give some people some perspective on what we're trying to do here at Ericsson in the UDN group. And so now the new name of the organization is called Edge Gravity by Ericsson. We're going to preserve the name of the UDN. It just becomes the actual network itself that we'll talk about today. Everything stays the same pretty much. The service is the same, the technology is the same, just a slight rebrand on the name of the organization. And what the organization has been doing for quite some time now is trying to sort out how operators can get back in the game when it comes to edge platforms themselves. And so back in May of this year in New York City, we were asked to keynote the CDN Summit, where we proceeded to tell people that the CDNs as we know it are going to have to evolve, think differently, and provide different services if they're going to scale and be around for another 20 years. Of course, we had to use a very a title that was going to be somewhat provocative, but ultimately we think CDNs are still a great application for the edge of the network that people understand, both from a technology and from a business standpoint. But ultimately, is there not more than just CDNs that we can talk about at the edge? And then the other thing that we've been discussing quite heavily is the fact that we fundamentally believe as an organization that the next wave of internet traffic won't scale without active participation of operators and ISPs or service providers here, as we call them. So we never miss a chance to make sure that folks understand the relevance of service providers in the entire ecosystem. And that we believe very firmly that the next wave of internet traffic and edge computing has a much stronger chance of survival and thriving than it does if we were to try and do it, without them. So what is the UDN network? So Edge Gravity as an organization now operates the UDN. It's our rendition of our Edge Cloud platform that's built in partnership with service providers. And it's really meant to deliver the next generation of edge scale applications from various targeted industry verticals that we'll cover today. Ultimately, at this stage, we have about 80 or so service providers who've agreed to join us in this journey. Today, we operate as a CDN, primarily in terms of what's bought and sold and how we do our revenue share with the service providers. And we're deployed in about 22 core locations, which I'll explain in a moment here. Our investment to the UDN network and our commitment to service providers to build something collectively global that people will have access to. That core infrastructure is largely built in Equinix data centers. In these major cities. Some of these locations have storage in them as well, but predominantly this is a large collection of servers and software. Mirantis is part of that software stack that we rely on to make all this magic work and this network connect in together. And then the operators have something to connect into. So this is the investment that Ericsson really has made in not only directly in terms of the technology, but also in the network that's interconnected via private MPLS backbone, and then all the software, hardware, and things that go into operating not only data centers, but the network itself from a global standpoint. And if you ask what it is that we're building, well, we're building what the Mirantis guys just told you earlier. It really is an incarnation of an edge cloud ecosystem with shared value for the service providers to actually tap into. We actually do take care of selling access to the infrastructure on behalf of the collective of service providers, or UDN service provider members, as we call them. And we've had an opportunity to really build something that was more modern, we think, than predecessors in the CDN space. So we were able to actually use, best of breed hardware, software, open source thinking, and not have to worry about brownfield environments when building something from the ground up. And although that may not last forever, it is an advantage that we believe we do have in terms of selection of technologies that make the network hum. And the day job that I have primarily is to find these strategic ecosystem partners. These are essentially people outside of just traditional CDN technology companies that want to bring their applications to the edge of operator networks globally and deliver their applications, their software, in partnership with service providers. And the industry verticals that we have looked at primarily are around gaming acceleration, TV and media, and a few others that Satish mentioned earlier in the smart cities and IoT area. But we're not really stopping here, because what we're trying to do is we're trying to identify real edge computing applications. And what I mean by that is, following these guiding lights that we have, or these North Stars, what we're trying to do when we're trying to build this cloud platform. And we're really not trying to build another centralized public cloud. We're trying to build this next wave of edge cloud, or edge compute, as some people will call it. But we're really trying to create a new segment in the market in partnership with service providers. Secondly, we're focused on building the platform itself. We're not really investing a lot of time and money into the individual discrete applications. And of course, we're trying to use modern technologies to scale and deploy these applications. And thirdly, we'll use partnerships essentially to create the applications to differentiate and scale that part of the network, and partake kind of in the SaaS side of the business. So building a new segment of public cloud computing, focusing on the platform, and ultimately using partnerships to differentiate and scale the software side of the business. All that to say that we're not trying to replace public cloud. We're actually quite grateful at what the large cloud providers have done in terms of changing the IT mentality from an inside-out type of a view of the world, and we'll continue to augment what's already been done in public cloud. So when we talk about real edge computing, it's really great that we can see into the future, but we also want to live in the here and now. And so when we look for particular applications to bring onto the UDN, we're maybe too selective at times, but very, very selective, and focused on applications that traditionally would run in current public cloud today, mostly because some people have already kind of made the leap from running their own IT and their own data centers into running into somebody else's infrastructure using modern runtimes, but focusing essentially on low latency requirements. So things that have very latency sensitive type requirements in terms of the applications. And those are typically expressed in round trip times or in milliseconds. Or in other cases, some applications that just cannot scale from an egress or from a bandwidth standpoint in centralized public cloud. And we'll give you some examples of those in a few minutes here. Ultimately, we try and make sure that the companies that we're working with see the UDN network and the service providers and their active participation as critical to their success, where we really are trying to provide a network that's a fast track to scale for these companies. And the last thing that we typically would focus on is technologies that are enabled by the UDN network. So things that don't necessarily exist today, that if people had access to thousands of edge locations and could deploy their software there, new services that could actually be created, much like public cloud enabled a wave of new services to be created by putting applications in large centralized data centers on the public internet. We believe strongly that there are technologies and companies out there that will thrive by getting access to the world's public edge cloud. And so all this to say that we're trying to live in the now, and we're really focused on these real edge computing applications, things that people can get their heads around very, very easily. And so we're not just making this up by ourselves. We actually spoken to a lot of companies. Your logo may actually be in this slide, and unfortunately I didn't have enough room to put them all in here, but we've spoken to probably 50, 60, 70 different companies over the last 12 months to try and understand, if we gave you access to 1,000 edge locations around the world, what could you do with that? How could your applications improve? How could you better service your customers from a performance, reliability, or user experience standpoint? And we've essentially selected, as of last year, 4 to 6 of those applications to take to market in 2018. And we will continue to work with some of these companies and additional ones from a 2019, 2020 deployment standpoint. And so the ones we've talked about publicly today are these 4 companies. One was just recently acquired by Roblox, and that was PacketZoom. But you'll see a theme of latency, of scale and bandwidth, and deployment at the edge that is really critical to each of these companies' applications. And I won't go into huge detail about them both. I'll let you go study them a little bit on your own based on the public information that we have. But if you do think that you need something from an SD-WAN or SD-Core standpoint, our partner Mode is willing to help with that. We do have a webcast for gaming acceleration coming up with our partner Haste on November 20th, which is next Tuesday. if you want more information about that. Packet Zoom really has been focused on mobile gaming and mobile e-commerce acceleration, among other parts where their technology is used. And Net Insight has been very focused on delivering low latency, true live screen synchronized video to help scale from a bandwidth standpoint, a better live over-the-top video experience. And so what we tell people publicly today, ironically, it's also what we tell people privately, is that the UDN is a live global network in 22 core locations with 80 service providers that are ready to grow with you together from an application standpoint. Secondly, CDN, albeit a great application for Edge, really is only the first application that the UDN network has been focused on. And we're currently incubating that next wave of Edge applications. And if you have any specific suggestions on other real computing or real edge computing applications, we'd love to hear what those suggestions are as kind of we shape the future of what the technology stack is going to look like for the UDN. And we're still very much in the CDN business, working with operators and their digital properties in a shared CDN model, which we believe is still a unique technology and business model for service providers who want to deliver their own content to their own subscribers rather than paying a global CDN bill every month. So together with all these companies and with you, we're really trying to create a brand new vertical for edge cloud and edge computing. We've published some research as well with some other like-minded companies called State of the Edge, which will be a bi-yearly publication. You can download that one at stateoftheedge.com. We look forward to additional participation from additional authors and contributors, and ultimately trying to make sure that the market and ecosystem for edge computing continues to thrive and be defined in a way that people can understand. And if you're looking for more information or want to contact us at Edge Gravity, you can get to our new website at edgegravity.ericsson.com, or certainly reach out to the Mirantis folks, which we're working with on a day-to-day basis here on looking at MCP and other deployment architectures that can be enabled by the technology we use from Mirantis. And to that, I'll pass it back to Nick.
All right, thank you so much, Eve. I really appreciate it. We're gonna take the screen back to Satish. Satish, you have the ball, so if you can head back there. Okay, so now we have some questions. If you have not already put your questions into the questions pane, please go ahead and do that. Also, I will draw your attention to, there is a PDF under the handout section. You can go ahead and grab that as well. Let's get into some questions. We've got some good technical questions here. So let's see here. Let me start with this. What performance parameters have you observed in terms of low latency and throughput in your trials and deployments? Satish, you want to take that?
Yeah. So currently what we have is the very first version of the Edge product. So we don't have a lot of performance numbers from field trials or POCs, but having said that, we have done a lot of performance testing with MCP and data plane acceleration techniques like SR-IOV and DPDK, and we have been able to get line rate type of network throughput with these. And of course, there are a lot of details behind that. For example, if you're using DPDK, how many cores do you dedicate for pole mode drivers, TX, RX, and so basically there are a lot of details behind that. So at a high level, with SR-IOV, you don't really consume a lot of CPU resources, and with the right configuration, you can get close to line rate even in the edge cloud. And with DPDK, you can achieve very high network throughput, but of course you are using up little bit of compute resources, quite a bit of compute resources on the edge side, especially to get very high network throughput. So as we do more and more trials and POCs with the edge stack, we will have more information on performance specific to the edge stack.
Okay. Can you guys hear me? No, I think I muted myself. No, I didn't mute myself. There we go. All right. Yes. So thank you very much. Next question. Eve, this one's for you. How do you guarantee low jitter and latency?
Okay, that's a broad one. The way we do it in UDN is actually in, I guess, two parts, maybe a third in the future. But we actually have built out our own private MPLS backbone, and ultimately we monitor that, you know, on a regular basis for performance, which actually measures jitter and latency between our sites and kind of between the whole different parts of the network with some software ultimately. But the second way that we've actually done this is we're actually letting people like Haste, for example, who actually specialize in low jitter and latency for specific applications, run their software, which actually not only monitors that last mile latency, but all the way back to the gaming servers themselves. It's a tricky thing to do. And the third thing that I think that we've seen happen so far is that the operators obviously have in the last mile network the ability to monitor and improve these services. So you'll see a lot of the different access technologies works very specifically on you know, slices in wireless or service flows in cable, for example, to actually make sure that they can see a consistent jitter and latency performance, so smoother jitter or less inter-packet gap, and you know, sub 5 millisecond latencies that are really being built into next-gen standards like 5G, for example, where schedulers are just going to operate that much tighter in terms of how they actually dole out time on these networks. Very complex thing to do in terms of guarantees. I think right now people are just trying to manage to a consistent user experience. But it's hard over the course of the internet. You know, you never know where these packets are going to go. So we've actually had quite a bit of interest from companies that specialize in, you know, smoothing out jitter and reducing latencies. So we'll continue with the acceleration application folks as well to make sure that we're staying abreast and aware of what's going on there on the technology standpoint.
Interesting. Okay. I've always heard it said, at least from the beginning, that it's not a question of how the internet. Oh, never mind. It was an old joke. I'm gonna let that one go. All right, Satish, for you, how does the Edge Cloud support mission critical services like MCP-TT, MC Data, and MC Video?
So how does MCP Edge support these? So obviously we are talking about the edge requirements. So when you talk about video requirements, we are talking about high network throughput guarantees, right? So there are multiple ways we can support that. Again, from a pure edge infrastructure point of view, basically two things. One is how the edge infrastructure itself is designed, right? So the edge infrastructure design, we make sure that unnecessary delays are obviously not introduced, especially in the data path, right? So this is where using enhanced platform awareness features like CPU pinning, huge pages, and also using some of the data plane acceleration techniques that I already talked about, they make sure that we get the best performance out of data plane, right? So and then it's you know, the other things in edge like edge and 5G, like network slicing. So if you have a specific application that requires very well defined characteristics, then the solution is to create a slice and configure the slice for that particular characteristic and use it for that application. Again, those are I mean, these are just examples that I explained, but using the capabilities of the edge cloud and the key requirements of the application, there are multiple ways to really make these applications work the right way in an edge cloud and 5G architecture.
All right, thank you. Okay, Eve, let's give you this one. Is there any edge computing / edge cloud architecture reference?
Oh God, I guess the beauty of reference designs is that there's as many specifications out there as you want to choose from. So there's lots of choice. I'd answer that by saying that it really depends on what you're trying to accomplish. You know, much like a home design, planning out, you know, the number of bedrooms that you want and bathrooms and how your kitchen is going to look is going to be a little bit different. So I don't think that there's been a lot of adoption, I would say, of different reference architectures per se. Although there's plenty of organizations out there that are trying to make suggestions on those, but it ends up being a decision that's made by, frankly, ourselves and the operator as kind of partners in this whole UDN thing. There's a lot of things that one operator can do that another cannot for various reasons. So not a lot of reference architectures per se that people have implemented without a fair degree of either customization, all the way down from selecting the type of hardware that they have an opinion on. You know, we do see a lot of hardware companies that feel that their hardware is going to differentiate the edge of a network, but nothing in terms of anything that I've seen anybody, let's say, pick up and deploy ubiquitously across multiple you know, parts of the network, which would make it kind of a reference deployment. Still very early days, I think, for references, and still a lot of opportunity to influence those reference architectures, you know, in a direction that makes sense.
Yeah, that's pretty much that's pretty much where we are right now. I agree with you on that. All right, Satish, what is your approach for detecting, containing, and repairing rogue apps or nodes on the network? And
Right.
Eve, if you have a comment on that too, feel free to jump in.
Yeah, so this is going to be very important as we deploy edge applications, because as I said in one of my slides, this is a completely new paradigm we are talking about, right? We are trying to converge the telecom networks with IT cloud-based approach, right? So all of a sudden you have an access, you know, telco access layer or a regional POP where you have some third-party edge application running. So it becomes extremely important to make sure that these applications have the right kind of access levels. In other words, a AR/VR application or a 360 video application written by a third-party vendor should not have the capability to make any changes to the infrastructure components at the edge. So extra care needs to be taken to make sure that the security levels are properly set up. So it's going to be a challenge, and solutions have to be put into make sure that that's achieved.
Okay. So this is actually for both of you. So there's a perception that to meet real-time 5G requirements, the edge cloud needs to be incredibly close to the UE. Excuse me. For example, at a cell tower. The edge cloud here seems to be planned at around 2,000 nodes. What would you say to an operator who believes that 2,000 nodes are necessarily too few and therefore too quote unquote far away to meet the latency budget? So Eve, let's start with you on that.
Sure. I like the use of the word perception there, because that's what it really ends up being in a lot of these cases. It needs to be incredibly close to the user endpoint. You know, in some of these cases, people are basically making the user endpoint the edge of the network, very specifically because they're nervous about the application needing resources in microseconds, for example. a lot of AI, for example, happening in the handsets, for example, or in different devices. A lot of processing of data happening in devices that are sitting, right next to the storage. And I think it's a deployment consideration in a lot of these areas, right? The scheduler, which is ultimately one of the points where that latency is either introduced or mitigated. I would be more concerned right now with less about the deployment architecture for where the nodes are and where the edge is, and really a better management of the networks and frequencies and bandwidth that's out there. I mean, just the amount of TCP retransmissions we see on mobile networks is still staggering today, and really is more. It's one thing to say that one round trip delay of 100 milliseconds is needs to be improved on, but when you have TCP sessions and sockets that are being opened, in the 30 and 40 and 50 numbers of transmissions, let's say, between that UE and the base station, that's where the delay and the performance problems are happening. This is why in India you see round trip times of over 1,000 milliseconds, just because of the sheer number of requests that are coming in and the additive compounded impact of already high latencies from that standpoint. So I'm not too concerned about the perception of latency in 5G and the deployment architecture. I think what you'll see is 5G gives us an opportunity to really rethink how we use spectrum and how we do a better job at working with application developers to expose what the network is undergoing at a particular point in time, so that we don't keep hammering it with requests just trying to get through what is perceived as a very narrow pipe that really needs to be better managed.
Okay.
Yeah, just to add to that, Nick, I think the overall deployment architecture and where you locate the edge clouds and what kind of edge applications run on which edge cloud, I think these are all going to be driven by use cases, right? So just to give you a quick example, not all applications are going to require the same kind of characteristics, right? If you have a mobile application, for example, a 4K video streaming kind of application, that's going to require extremely high throughput, low latency. But when you think about a lot of IoT devices, right, and industrial IoT devices, sensors, and those kind of devices, you're going to see thousands and thousands, large number of those devices, but each one is the bandwidth requirements are going to be low. So in general, I think a lot of these characteristics are going to be decided by the use case, and that's going to drive the overall deployment architecture and where things are placed.
Okay. All right. So we are coming to the end here. So I'm going to do two things. First, I'm going to ask Eve. I'm going to give you one more question, sort of a rapid fire question, and then I'm going to thank everybody. So give me a minute. Eve, why would an operator join the UDN network?
Well, the biggest thing that we've seen from the operator so far is it's a very low risk proposition in order to go learn about the edge, but more specifically about creating a strategic seat at the table for them as an operator, as part of a much larger collective of operators, to go and do something uniformly across the industry. We've learned now over the last 12 months that application people that you think really don't like operators or don't want to work with them is actually not the case. They just don't have the ability to go talk to 500 operators globally, nor do they have the ability that if they did talk to 500 operators, go and re-platform their software 500 times for 500 disparate environments. So they really, really do want to work with the service provider community. And we believe that that those operators should join, so we can help them create a ubiquitous, uniform, collective way of deploying applications across their footprint and bring them back into the value chain.
I am so glad that that was your answer, because that gives me a perfect segue into what I was going to say next. And speaking of trying to find a uniform way of doing these things, I will invite you again to download the MCP Edge demo appliance, try it out, and please, we really are interested in your feedback on how you want these things to work for you and what you think the standard should be. So I will remind you again about that download. And I will say thank you to everyone who joined us here today. Eve, I know you're very busy. Satish, I know you're also very busy. And all of you who are listening to us today, I know you are all very busy. And so we thank you for your time, and especially Michelle Yakura on the back end, without whom we could never get all of this done. So thank you all, and we'll see you next time.